Every day, we generate vast amounts of organic waste. From household food scraps to agricultural residues, livestock manure, slaughterhouse byproducts, and sewage sludge. Even disposal of animal carcasses during disease outbreaks is a serious challenge for society. Yet many countries still rely on outdated, inefficient waste disposal practices. They mix organic and inorganic waste together, then bury it en masse underground. This approach has become a ticking time bomb for humanity's survival. It is now recognized as a major source of methane emissions and a serious accelerator of the climate crisis. According to the U.S. Environmental Protection Agency, methane produced when organic waste decomposes anaerobically in landfills can be up to 28 times more potent than carbon dioxide over the short term. In the U.S., municipal solid waste landfills are among the top 3 human activity sources of methane emissions. Globally, the waste sector accounts for roughly 20% of all methane produced by human activities. Even more severe is the leachate released from landfills during rainfall. This leachate contains a high concentration of organic and inorganic compounds, heavy metals and pathogens, a hazardous chemical soup. Without proper containment systems, leachate seeps through soil into groundwater aquifers and flows into rivers and streams, damaging water quality and aquatic ecosystems. Even a small volume of leachate can contaminate large groundwater systems and waterways, rendering water unsafe for drinking or daily use, posing a serious risk to public health. Thus, mixed waste landfill disposal carries risks of pathogen spread and leachate pollution, and permanently wastes the opportunity to slow global warming. It is the most inefficient and inhumane way to handle waste. We can no longer stand idly by, but this very waste holds enormous potential as a resource. Today, we present a revolutionary solution to this issue. The biogas plant is a system that transforms waste into clean energy and organic fertilizer. Developed by US-Korea joint venture, DHM Global Incorporated, and MTG Global Incorporated, on world-class proprietary technology is the key to a truly sustainable future. DHM proposes to utilize organic waste to produce renewable biogas and organic fertilizer through a dedicated plant. This facility is designed to process up to 1,000 tons of waste per day, a large-scale waste processing system. The core technology is the anaerobic digestion method. Under anaerobic, oxygen-free conditions, microbes decompose the organic waste, producing biogas, and the residue is recycled into high-quality fertilizer. With over 20 years of field experience and ongoing R&D, DHM has established optimized operational parameters for any type of organic waste. Municipal solid waste is sorted, mixed with food waste, then fed into automated anaerobic digesters. Generated biogas is refined and used to produce electricity and heat. Byproducts include organic liquid fertilizer and compost. All processes are automated, maximizing efficiency and reliability. The beginning of biogas production is the importation of organic waste. Various organic wastes, household trash, food waste, animal manure, sewage sludge, are transported via dedicated vehicles to pre-treatment facilities. Upon arrival, waste is weighed, sorted, then moved to storage tanks. Impurities such as metals and plastics are removed, then waste is shredded and pulverized. Heavy materials like sand, shells, or stones are separated out. The waste is then homogenized in a tank, adjusting temperature, pH, and solids to water ratio to optimize decomposition efficiency in the digester. The pre-treated waste moves into oxygen-free digesters. Microbes decompose the organic matter, generating methane-rich biogas. Digesters are maintained at a mesophilic temperature and continuously agitated for uniform digestion. Over a retention period of approximately 20-30 days, most organic matter is broken down, producing a significant amount of biogas. The fermentation follows hydrolysis, acidogenesis, acetogenesis, methanogenesis. Different microbial communities act at each stage. Imbalance can cause failed digestion, reduced gas yield, or odor issues. Therefore, daily monitoring of digestate and maintenance of equipment is essential. Generated biogas is transferred to storage tanks for holding, but the gas contains impurities such as hydrogen sulfide, moisture, and CO2, making it unsuitable for immediate use. In purification units, sulfur is removed, moisture dried, and CO2 removed if necessary. After purification, the result is high-quality fuel, comparable to natural gas. The purified biogas is used in a combined heat and power CHP system to generate electricity and heat simultaneously. Alternatively, it can be combusted in boilers for direct heat, supplied to gas pipelines, or used as vehicle fuel. If desired, reformers can convert it into hydrogen as well. All operations are managed by real-time monitoring systems, ensuring safe and efficient operation. After digestion, the remaining sludge moves to an intermediate storage tank for stabilization. Then, it is separated into liquid and solid fractions via specialized dewatering equipment. The liquid becomes digestate, liquid fertilizer, and solids become compost feedstock. In this process, moisture content is reduced to below 80%, improving treatment efficiency significantly. The liquid fertilizer is not used immediately. It undergoes honest end-to-end fermentation for odor reduction and pathogen elimination. With pH adjustment, microbial inoculation, and 30-40 days of fermentation, a stable, safe liquid fertilizer is produced. The finished fertilizer is stored in sealed tanks, ready for application in agricultural fields. This final liquid fertilizer, rich in nitrogen and potassium, serves as an eco-friendly organic fertilizer that can replace chemical fertilizers. For farmers, it becomes a low-cost, high-efficiency green resource. The solid sludge still contains abundant organic matter. Carbon-rich bulking agents like rice husks, sawdust, or straw are mixed to start composting. By balancing carbon to nitrogen ratio, aerobic composting proceeds with ample air supply. The composting temperature rises above 60 degrees Celsius. During this hot fermentation, weed seeds and pathogens are eliminated. Composting and maturation take approximately 90-120 days. Then impurities are removed, and material is processed into fine compost particles. The finished compost is packaged and supplied to local farms, and also used in urban agriculture or landscaping projects. Organic matter that was once mere waste is reborn as life-giving fertilizer for agriculture. This project goes beyond environmental impact. It proves its value through financial stability and high returns, the core criteria for any investor. We focused on key financial metrics: internal rate of return, and return on investment in commercial renewable energy projects. It's typical to target an IRR of 20-40% over a 20-plus year operational period. But DHM's 1,000-ton-day biogas plant, with its stable and diversified revenue structure, aims for long-term high returns beyond those expectations. With a total project cost of USD 520 million, this facility leverages economies of scale typical for large plants, maximizing operational efficiency and productivity relative to initial investment. The driving force behind the exceptional ROI of our project lies in its clear, diversified, and highly resilient revenue structure. Through the annual production of 40,150 megawatt-hours of renewable electricity and thermal energy, we have secured a long-term and remarkably stable stream of income. Waste intake fees form the financial foundation of the plant, providing a steady and reliable cash flow. that supports every stage of our operation. From the byproducts of the process, we produce 66,000 tons of organic compost and 231,000 tons of liquid fertilizer each year. These products are sold at premium prices in the expanding organic market, creating an additional and highly profitable revenue channel. And with more than 148 tons of greenhouse gases reduced every year, our project is recognized for its significant environmental impact, unlocking powerful returns in the rapidly growing carbon credit market. Together, these revenue drivers form a forward-looking, future-proof financial model that maximizes profitability while contributing to a cleaner and more sustainable world. The return on investment of our project delivers overwhelming value. Our DHM biogas plant not only protects the environment, it also stands as one of the most reliable and stable investment opportunities, offering investors an ROI that truly exceeds imagination. Depending on the financing structure, our project delivers extraordinary returns based on a total project cost of $520 million, with partial investment contributing 10% of the total cost. The expected ROI reaches 35%, with full investment covering 100% of the project cost. The projected ROI rises dramatically to an impressive 358%. This diversified revenue portfolio shortens the investment payback period and serves as the foundation for delivering top-tier IRR to our investors. The DHM biogas plant is a truly future-proof investment, one that solves environmental challenges while delivering stable, attractive, and long-lasting financial performance. Our technology is already proven, with planning, construction, and operation experience of 22 demonstration plants. Its reliability and effectiveness have been demonstrated. This goes beyond simple incineration or landfill disposal. It transforms waste into high-value resources through innovation. The organic fertilizer produced in this project offers a sustainable solution that surpasses the limitations of conventional chemical fertilizers. Chemical fertilizers may supply nutrients immediately, but over time deplete soil organic matter, harden the soil, and hinder healthy plant growth. Excess compounds can pollute groundwater or rivers, potentially entering the human body through crops, posing health risks. In contrast, the organic fertilizer from DHM's plant, rich in live microbes and organic matter, fundamentally improving soil's physical properties. It enhances moisture retention and aeration, supporting healthy root development, providing farmers with an eco-friendly and cost-effective fertilizer resource. This enables organic farms to self-produce fertilizer, becoming a foundation for sustainable agricultural competitiveness. Our organic fertilizer does more than supply nutrients. It completes the circular resource cycle by returning waste to the agricultural ecosystem. On SPC-provided land in the US, with a budget of USD 520 million and a 36-month construction period. Once this plant is completed, we will build a self-sufficient, sustainable energy society, offering a concrete solution to global warming. This project isn't merely an investment. It encompasses waste problem-solving, environmental protection, and new industry creation. It is an investment in the future. We invite your interest and participation. Thank you for watching the presentation on the innovative technologies and vision of our biogas plant, proposed by DHM Global, Incorporated, and MTG Global, Incorporated. Before we move into full-scale investment discussions, we have organized and detailed the most frequently asked questions from business operators and technical experts in a Q&A format. Through this information, you will once again be able to confirm the stability and profitability of our project. What is biogas? Biogas is a combustible gas generated when organic waste is decomposed through an anaerobic digestion process. Its main components are methane, carbon dioxide, and trace amounts of hydrogen sulfide, nitrogen, ammonia, etc. It is used for fuel or electricity production. What are the main facilities of a biogas plant? 1. Feedstock reception and pre-treatment facility. 2. Anaerobic digestion facility. 3. Gas purification and storage facility. 4. Power generation facility. 5. Liquid fertilizer digestate production and storage facility. 6. Compost solid fertilizer production and storage facility. What are the main raw materials for biogas? The representative feedstocks are as follows. 1. Livestock manure. 2. Food waste. 3. Sewage sludge. 4. Agricultural byproducts. 5. Organic waste. What byproducts are produced in a biogas plant and how are they utilized? The digestate remaining after biogas production can be used as liquid fertilizer or compost. These byproducts are rich in nutrients and are recycled as agricultural fertilizers. What are the methods of energy production? 1. Combined heat and power produces electricity and heat simultaneously using biogas as fuel. 2. Boiler, direct combustion to produce heat. 3. Upgraded biomethane production, purified to natural gas quality and used as city gas or vehicle fuel. 4. Hydrogen can be produced using methane reformers. What is the economic feasibility? What is the revenue structure? The main revenue sources of a biogas plant are 1. Electricity sales. 2. Heat energy sales. 3. Sales of purified biogas as city gas or vehicle fuel. 4. Waste treatment fees. 5. Sales of liquid fertilizer and compost. 6. Carbon credit sales. What are the environmental benefits? 1. Reduction of greenhouse gases. 2. Mitigation of waste disposal issues. 3. Odor reduction. 4. Resource recycling. 5. Reduction of fossil fuel use. What are the major risks to consider during operation? 1. Instability in feedstock supply. 2. Risk of gas leakage and safety accidents. 3. Equipment failure and maintenance issues. 4. Odor management challenges. 5. Excessive digestate generation and disposal difficulties. What permits are required for installing a biogas plant? 1. Approval for installing waste treatment facilities. 2. Environmental permits related to air and water quality. 3. Building and civil engineering permits. 4. Energy generation related permits. 5. Permits for producing liquid fertilizer and compost. How many personnel are required to operate a biogas plant? It varies depending on the plant size, but for a small to medium plant, 15-20 on-site staff are needed. Main tasks include feedstock input and monitoring, equipment maintenance, digestate management, and safety inspections. Automation systems can reduce staffing needs. Why can a biogas plant cause conflicts with local residents? The most common causes of conflict are as follows. 1. Odor emissions. 2. Increased traffic and noise due to transport vehicles. 3. Concerns about soil pollution from digestate management. How is biogas production volume predicted? 1. Biogas generation varies depending on the type and characteristics of the feedstock. 2. Volatile solids vs. content of the feedstock. 3. Hydraulic retention time, HRT, and temperature in the digester. 4. Digestion efficiency. How can odor be effectively reduced? To effectively reduce odors, structural design and odor treatment systems must be comprehensively considered from the design stage to minimize complaints during operation and maintain stable facility performance. Structural design elements. 1. Design feedstock inlets, digesters, and storage tanks as sealed structures to prevent odor leakage. 2. Install local exhaust systems at odor emission points. 3. Install sealed collection lines in odor-prone areas to prevent external dispersion. 4. Maintain negative pressure in odor zones to prevent outward odor leakage. 5. Control airflow to prevent odors from moving to clean areas. 6. Combine natural and mechanical ventilation to promote indoor air circulation. Apply a combined odor treatment system. A multi-stage system combining a scrubber as the first stage and a biofilter as the second stage can effectively remove both low and high concentration complex odors. What is the installation cost and investment cost per ton for a biogas plant? Minimum USD 300,000 per ton till the maximum USD 600,000 per ton. The installation cost per ton varies greatly depending on plant size, type of feedstock, technology, equipment configuration, automation level, and conditions of each country. After the plant is completed, the investor may find it difficult to operate due to lack of technical expertise. How is post-construction operation handled? Since the facility requires professional operation and management even after completion, the technology provider usually operates the plant directly for a certain period after construction. For investors without operating experience, contracting an O&M specialist company initially is the safest option. After 2-3 years of stable operation, it is possible to transition to technology, transfer, and direct operation. In other words, completion, the end. An operation plan must be included in the business model. What is the minimum and maximum processing capacity for constructing a biogas plant? Biogas plant capacity does not have a fixed minimum or maximum specification. It varies depending on feedstock type, operation method, installation purpose, and the capability of the technology provider. However, based on actual domestic and overseas cases, the typical minimum capacity is around 100 tons, and there is no upper limit. Thank you for watching until the end.